Okay, so we had an introduction to Boolean logic, and now we are going to dive into that in more details. So we learned how different types of comparisons, like where we get a Boolean value, whether it's true or false. We looked at how we compare two numbers and how, like, to compare two strings. So if we try to compare two different data types, for example, I'm going to compare string against a number. So what I can expect, so in this case, you are going to get an error for sure because you are trying a numerical value against some text, and that does not make any sense except for like equal and not equal. Okay, so so many times you are comparing things that have probably different types. The only operation that work are equals, I would say, and not equals. Okay, these two probably, but for others, no. So if you try to do greater than, for example, or less than, or greater than, or like, for example, or equal to, or less than, or what else is left? Equal or greater than. So for all the remaining operators, this is going to generate an error. So you can just eliminate all of them. Just it works probably for the case of equals and not equals. Okay. So this is the idea. And we are going to try now some example. Let's go back to our pie chart. I'm going probably to keep the same code for this class. I'll probably share only one code for everything. And let's try this now. We did it before for let's have for what we had before. We had x and y. One of them is equal to 2, one of them is equal to 5. Okay, so what we will have today is we will keep one of them is equal to 2, and the other one is equal to 5. But this 5, I'm going to consider that it is a string. You see, when I'm putting the quotes here, this means that this 5 is not interpreted as an integer anymore. Okay, so let's check if these are equal. Okay, we can have two here, just even that they're two equal, but they're different data types. So in this case, what you have, oh, you have nothing. I would ask you to pause the video and think why you maybe have nothing. What happened? Okay, so here I am making a command, and this is why there is nothing. It's just reading this like line, and this line is fine. I'm defining some variables. And then if I'm going to execute this, then it's false. So how it's coming, how it's false. Okay, this is not an error. It can happen due to the version in Python, okay? But isn't 2 equal to 2? It is. So it's supposed to give true, right? So why and how it is interpreting all this, okay? So mainly how it is doing that for this 2, if we, so it's reading it as a string, and there is a conversion, okay, to the string. So the value is not 2 anymore. And for this 2, it's mainly 2. So comparing 2 with a different value, then this is mainly generating false, which is corrected, it's false. It can probably, if you are trying with a collab or different ID, you can have error also, and mainly this is expected as well. Probably it's type error. This is the famous error of type if you are trying to compare two things which are having different types. Okay. So let's keep it on and try with the not equal now. What can we have for not equal? So if for equal we are having false, then For not equal, we are having to think this 2, which is a number, is not equal to 2 that as a string. So true. Now, let's try with the less or greater than and less than. For these, it's expected the type error no matter what, like you have version. Yeah. So this is like, it's not supported between, you cannot compare like less or greater than or less than between two data types which are different. So it's saying not supported between instances of int and string. Okay, so this is mainly the idea, and we are comparing this. So it's already moving to the next slide. Fine. So this is a huge source of confusion probably in this slide. So if I have two equal signs, okay, and I have one equal sign. So do not be confused. So we are going to clarify this today. So one of them is an operator when like, and the other one is also an operator. So what is the difference? Is when we have the like double equal, it's I am asking a question and I am going to get a Boolean which is true or false as a return. But if I have one sign which is x equal to 5, for example, which means in this case I am assigning to x, I'm giving it this like value, exact value 5. Here I am asking, is x equal to 5? And so for this question, the answer is yes or no, which is a Boolean. And for this one, it's just going to do that, to do the job for you. It's going to put 5 in the number, in the value as a value for the variable x, okay? So, and we are not expecting any kind of response in this case, okay? So there is also what we call Boolean operator, and so this is like if you have two variables and there is the AND Boolean operator. So let's do real world example first, and then I'll come back to that, okay? So in programming, this has a more formal representation where we evaluate two different conditions and they are both true, and then like for example the AND operator will return true, and we will look at a lot of different examples of how this works. So mainly it's going to be about this. So the notation in Python is x and y, so we keep writing it and, okay, and so it's also here maybe, yep, it's the same, x and y. Okay, so in Python it's recommended like this, and probably you might need to pause the video and ask me why, and answer probably yourself why. So here we have the x and y, they are in lowercase. And we mentioned last time, so if they are variables in Python, it's recommended like that. But here they are just in like uppercase because it's just the truth table and just showing you, okay? So, but in Python, this is mainly how it is recommended to be written, okay? So x represented, represents, we'll go and see an example. So the example will cover later is going to be Troy availability, and Y is someone else, which is Abbott availability. And so we are going to apply this truth table to Troy and Abbott like case. So what will happen that Troy and Abbott are going to host a morning show. So together they are they are checking their availability, okay? So there is only one way possible to have this show is when both are available. So this is the only way to the show to take place. If so, is like if Troy is available, and at the same time also like Abbott is available, okay? So they both have to be available. So for example, if I have Troy availability, I am going to represent or like have this variable Troy availability. Okay, so and it is a Boolean, so value. This Boolean value can take whether true or false. For Abbott availability, it can take true or false, but for studying all the possible cases, we have 4 possible cases. Troy is available and is not available, Abbott is not available. Or Troy is available and also Abbott is available, or one of them is available and the other one is not available. Okay, so this is what we show or represent in this truth table, I would say. And in this case, we have our variable, which is the show. It's taking both Troy and Abbott are available. Okay, so when the show is having the value true, is when both are available, which means that these 2 variables are having the value true. True and true gives you true. Any other case where one of them at least is false, it results on there is no show, it's false. Okay, so this is mainly the idea. And we are going to just try to go again to our pie chart and let's try to have or work in this example. So for this one, I'm going to keep this error. We're going to see when you're going to open my code just for you to learn. Otherwise, so that means I would say this. This like generates error. I would say type error. So you don't think that something is wrong, honestly. No, this element, they totally have different locations. Uh, the letters in the keyboard. Okay, and so we're going to have our example. We are okay. Okay, so we are what we have. We have our first, what was the name? Troy, okay, and we have also Abbott. So Abbott availability, I would say, is mainly we think that he's not available. Okay, and just let me try something with you here. I was just mentioning this before, but I want to see. So if I mention false with the little f and I run this code, what I will see over here is an error. Say false is not defined. Did you mean false? At least here is giving you a hint. So this is what I mean. Yep. So you must make sure that you are writing with the like uppercase or capital letter. Okay, and the next one is we have that Troy available. And this one probably, let's say, yep, is available, for example. Okay. And next, so we have now our show. Okay. The show is a variable which is having Troy avail, this like variable we defined so far, and at the same time this one. So both of them. Okay, so avail. It's just we have the and in the middle, and in this and we do not write it in big A, so just lowercase, and Troy avail. Okay, so this is for the show. Until now, if I run my code, there is nothing expected to be, there is nothing to print, okay? This is why there is no errors, which is good, but there is no result. Now, what we want to see is that, is this show happening or not, okay? So one of them is available, the other one is not available. Let's see, print, yeah. So the show here is going to evaluate that is the final like answer. So the final answer in this case is false, which means that its show is not going to happen. Okay, and that's the same exactly if I do print Troy avail and Abbott avail. So I'm going to print exactly this. I'm going to use the variables, and I'm going to run. So it's giving the same result. So it is false. Okay. So basically, this is the idea that I just want to show you here. And let's move to the next slide where we have a different operator, which is the OR operator, okay? So for the OR operator, so it has a different truth table. And so mainly it's a little bit more flexible, I would say. So this is the formal truth table. And in Python, it looks like this if we have the X or Y, okay? And so the main reason we are going to use this is when we learn about the if statement. So we are going to learn the if statement in the next about the if statement in the next video. And so we are going to focus more on this. So what I want to make sure is we understand the basic of this logic first, and then we'll move to the if statement. But we have more flexibility, as I'm mentioning. So or means that at least one of them is having the value true, is more than enough to have true. So the only case this like truth table is having false is only when both of them are false. Okay. So for example, we come back to Troy and Abbott, and let's suppose that they live in the same apartment or they live together, okay? So if either one of them is home, then somebody will make a coffee, okay? And I'm a coffee lover. So the coffee now gets made when at least one of them is at home, okay? And so you can see that means the value of coffee is equal to true and like more frequently. So here we see in the truth table, this is like true for 3 times, and like only one time this variable could have the value false. So which again, like is like the general rule, only if at least one of them is equal to true, then this is how or why the coffee value is having like true. Okay. And so if you want that, we can go again and try to type this code. Let me comment this first. I keep all this history with you in the coding like file I share with you. So mainly let me make it clear for you. So for this one, it is mainly about the AND operator. And this one here, we're going to learn about the OR operator. Okay. Okay, operator, no problem. So we still have in our variables now, they are going to be, instead of Abbott available, so we have Abbott, I would say home, and this suppose that is home. Oh, this not. Why I'm still insisting. So when your brain is learning something, we just want to keep. So and the other one is Troy and home. Okay, we will also consider that this is true, and I'm saying that it will not work. Okay. So now what we have, we will not print them. Sorry. So we have coffee. It gives me the mood to just drink a coffee right now. So coffee is equal to what? We are going to mention that it's when like Abed is home or Troy is home. Okay? And in this case, let's try to print what coffee has. So it's true because both of them are there. Okay? Perfect. So nothing to worry about in the Python class, just need to enjoy it. And please, if you have any questions, never hesitate to ask me. I am always available, okay? So this example we see. Now there is another operator. So it's the not operator. Okay. So the not operator is literally just opposite. Now the not only works with Boolean value. Okay. It doesn't work with numbers or strings. It's only for false, the not false is true, the opposite, and for true, the not true is false, which is again the opposite. Okay, so it doesn't work if my x, I have, for example, not x has having a different like 3 or not 3, or no, it doesn't work in this case. Okay, that's not the not operator. Now if what I will do, I can mix Boolean and comparison operators as well. Okay, so first example here, I can have 4 is less than 5 and 5 less than 6. So in this case, it gives true. This 4 is less than 5 and 9 is less than 6. So this is false. 9 is less than 6, for example. Okay. So I have here 1 is equal to 2 here. Yes or no? No. And 2 is equal to 2. Yes. So at least one of them is yes. Then the result is yes. Then 1 is equal to 2. No. And not no means false. Okay. And not false is true. Okay. So it's kind of things like this. If you want that, we can again try this like in our PyCharm, for example. Okay, let me comment. Oh, oops, again. No, I think I need a coffee. Okay. So what we have here is I have numbers. Okay, let's just try, but the memory in this case is not that much. So like this. Okay, why not? Okay, so we're going to print what we're going to print. We're going to print if, for example, 4 is less than 5, and what we have in the right side, 5 is less than 6. Okay, so try to see this. It's just true. It's true. So we are just kind of trying to type all this. So you can simply, or I can do it. So we will have print. Okay, first hand we have 4 less than 5, and the other hand 9 is less than 6. And in this case, I think something is missing. Something's missing. Yeah, something is missing. Okay. Sometimes you feel it with feeling. So it's this reinforcement learning in AI. So with feeling, you start like just something is wrong. Okay, so nothing's wrong now. So it's false. And so this one is false. Okay. And then we go to the other one and we try to print. So the print function we are just using to see the final result. Okay. Because if we just write that, it could be considered as a value. We're not asking the Python like interpreter to do anything. But what we really want is that we ask it to do something, and we ask it like basically to answer the questions. If, for example, 1 is 1 equal to 2, and or sorry, 2 equal to 2, and in this case, so it's going to give you the false or the answer true, sorry, like we were just explaining right now. Okay, and so on. I'll finish this one. Okay, not 1 equal to 2. Also, if I do this, I'm doing like, see, there is nothing showing. These are the results from previous previous three prints. So this is what I was just mentioning. I need to write here print. Okay. And if I'm printing, then I will having the true as a result. Okay. Oh, so see, here I have the true. See? So I have total four for each line of code that I'm writing. I'm having that answer for it. So this is mainly how it works. Okay, okay. And so this is for mixing and I would say Boolean and comparison operators together. Yep. Okay, so we did this. And now probably this can be for this kind of questions I can give you in the exam. Okay, so this could be an exam question. This kind of questions probably you can have as homework. Okay, so or it depends. Okay, so but the other type we can have it in like as an exam question. Okay, here what we are going to do. Here I am going to flow the order of the operation, okay? And I'm going to do some basic math. So what's, for example, 2 plus 2? Okay, I will ask, then I will answer 2 plus 2 is equal to 4. And I could evaluate it like this. I'm just separating the questions that I want to ask, and I am separating them mainly based on the and, okay? So here I have this question, then I have and I have this question, and I have and I have this question. So what I can do or how it works, I will answer the question to evaluate this and keep like true or false. This and stays, I evaluate this, keep if it's true or and. Again, I keep the and, I evaluate true or false. Let's suppose this true, this true, this true. I suppose I'm not ever reading that. And then what I will do is that final Boolean values true and true and true. I know that from the like table, true, all true, then it's giving final result true. So it mainly works like this, okay? So I have this example if you want that we can just try to print and we see what it gives each time, okay? So I will just go for so this example I need to, okay, we will have together. Okay, so 2 plus 2, 4, and not 2 plus 2, 4, and 2, okay. We will go for this one. We'll just comment all of this to save for you guys. And let's try to have this. So what we'll do, we're going to print, and what we have is 1, 2, 3, three like different things that we will evaluate, which are separated by and. This is what I remember. And so I'm just keeping them empty. So the first one, if I remember well, it's 2 plus 2, and then 2 plus 2, okay, equal 4. The second one, it's not 2 plus 2 equal, double equal 5. And the last one is 2 times 2 number equal, double equal 2 plus 2. Okay? So I think there is no errors. Okay, there is no errors so far. Okay. So let's run it. Okay. And this one gives us a final result true. Now let's try to interpret this. If we somehow try to understand the logic behind getting these two. So as I'm mentioning, we have mainly three like elements, and between these three elements we have and. So the first elements now, if we want to evaluate this, 2 plus 2 as I'm mentioning is 4, and is 4 like equal to 4, then yes. So this one is true, okay? Okay. And so we have true, and what we have now? We have 2 plus 2, which is 4. Is it equal to 5? We say no, means false. But this false, has before it just not. So we maintain that not, so we keep it. So not false, we have it for this one is exactly not false. And now, next one, what we have? This one. So this one is mainly 2 times 2, which is 4. Is it equal to 2? Yes, it is equal to 2, which means true. So this one, we need to write true. So now, let's say, this is the concept, okay? I will keep moving forward, okay? So if we consider these two, it will be working like this, okay? So it is mainly, this one is still not clear, okay? So we are going just to have the equivalent for this one, which is true. We have nothing to do with that. And not true, not false, which is exactly equal to opposite of false is true. And for this one is true. So we have print true and true and true. Now, how is going to work? This all is exactly the same as printing true and true is going to be equal to true. So it will be happening like this. It will mention true and true is true, okay? Then, and the other true, which is this one, okay? And then again, we will have true and true, which is true. So at the end, it's going to give you kind of print true. Okay? So, oh, the problem P must always be letter. Okay. You see? Okay, so let's run it. Just all this we're already mentioning from the start is giving you true here. But here I'm just doing you the extra steps to show you the different details that will give you that is true at the end. So you see, it's true. Okay? Mainly, this is how it's thinking, but it's always true. This is how we are coming up to the final result. Okay? So mainly question about the order. Usually we do the math first, and we do them like for each like two with respect to the order exactly like we work in math. So you can add also the parentheses to make it more clear. And mainly, so that's it for this video. Okay, thank you for watching.